My name is David Ward-Gittos. I'm a senior structural consultant with Petrofac Engineering Limited. I've got about 33 years experience, having graduated in 1980 from Loughborough University. During that time I probably spent about 20 to 25 years in the oil and gas industry, designing fixed and floating structures. But also I've designed buildings, including office blocks, and even down to renovating my own house. The Institute of Structural Engineers has a perfect definition. It defines structural engineering as a science and art of designing elegant and economic structures that can safely resist the forces that may be subjected to. Now there's some key words in here in terms of art turns up in the definition, and so does may. Now what structural engineering can be is a very intuitive subject. It's unusual in some regards as other engineers. I would look at a structure and its stability, how it's framed, where the load path goes, and its build method. All these things don't require any mathematics. I will draw the solution in a sense. I will frame it. There'll be certain elements of scale and size that actually dictate what that structure may or may not look like. That can all be done at the beginning by intuitively drawing the thing. This is the artistic part of structural engineering again. Engineer has to second guess what this thing will look like. Statistics is a tool that I use frequently as an engineer. Most students would have got into civil engineering or structural engineering via maths and applied maths, but the one that you probably not have done a lot of is statistics. The estimating the forces that subject may be subjected to is now full of statistical analysis. One of the things I'm tackling with currently on a particular project is the differences between a land-based structural design and how offshore technology creeps into us. One factor is build method. The way these offshore structures are built is primarily welded construction. Land construction will essentially use piecemeal construction. It will use bolts to bolt things together, and it will be built in bits that a man can handle or a small crane can handle. Offshore, we'll have cranes that can lift 10,000 tons, and they're so large that they dwarf buildings that are alongside a building on land here. So we are talking about a modular construction. As a consequence, we have very, very high usage of plate girders. We have a very, very high we'll almost certainly weld everything you can think of in terms of maintaining continuity of structural form and also negating corrosion, because we're obviously in a marine environment. Most fun element in some ways is where it's evolved in terms of it's exciting to see how structures of this magnitude could be installed in a very hostile environment. It means also working with a lot of people, a lot of skilled people. The cross-discipline interaction with chemical engineers, instrument engineers, electrical engineers, piping engineers, architects, that interaction of people and trying to arrive at a satisfactory solution is probably the most fun part. Challenges, in some regard, the challenge come out of structural engineering out of intuitively not having quite got the right answer. 90% of the engineering now is analytical. The engineer goes back into a regime that's probably familiar from other professions. He'll analyse this thing till forever in some regards in terms of what loads it will experience. Wave loads, lice loads, dead loads, operating loads, contents loads, thermal loads, all manner of loads. He'll analyse that structure for every conceivable case. The hardest bit is at the end, is if he has problems in that configuration, and that's the challenge. Every structural engineer should have a little bit in reserve for those days when it doesn't quite go as planned. Key skills obviously reflect parts of what the students have got into university in the first place. They need a very good analytical, mathematical mind, obviously, in terms of what they're doing. They use maths, and they will continue to use maths for the rest of their lives. I meet friends socially who can't remember and look in horror that I can still remember what a sine theta of an angle is. They would never use that. We will use maths. We will use physics and applied maths, We will use statistics, which I just mentioned earlier. Those are essential skills, but oddly enough, in structural engineering is this artistic bent. The engineer must be able to draw. He must be able to visualize in 3D. That right-hand side of the brain bit that people may have read about starts to become quite paramount in this particular profession. In terms of a good structural engineer, as I just described, can already visualize what the structure looks like without having to do any maths or physics, and can draw it, and will know intuitively that that's about the right structural form. Engineers who start this field, they'll enjoy what they're doing, actually. You'll find that as a reward, sometimes the structural engineering doesn't necessarily reward what you expect in terms of salaries or benefits or whatever it is, but it's a very rewarding profession in terms of what you achieve. I can see buildings that I've designed on land, and also for the ones offshore I won't get to see too often. But the ones on land I can recall, and it's a very rewarding experience. So it's terms of it's a very fulfilling environment. You're essentially creating, and creative occupations, I think, probably are always very rewarding. I've interviewed lots of graduates. I was head of department as well, my previous thing here. And in the mystery is how I pick, or what students I pick from a CV that comes to my desk. The CVs and skills that we have to differentiate some in this horrible world, in terms of there are lots of graduates coming out with a 2-1 or first class honours degree in civil engineering, or master's degree in civil engineering. The thing that employers look for is, in some regard, exactly the same what I'd look for a senior person. The person has to offer me something I want. He has to have a value, a product that can be used by the profession he's joining. So the engineer who's doing his master's now at university has got to choose that subject with a view to having an end product at the end of it. I think it's my biggest bit of advice. Picking that topic is huge. If you can find a mentor in industry, or when we do mentor students through masters in Petrofac, if you can find that bit of advice that chooses what would be useful in this list, or come up with an idea yourself in terms of what may be useful, you have something to sell to an employer. That's what an employer really wants. Even if it's only a few months of work, just that little subject matter would be enough to make an engineer, a manager like myself, say, that's of use to me. That in itself differentiates amongst everybody else. Yeah? At master's level, you've got to start picking something that you're going to go towards. So if it's carbon capture, or if it's dynamics of structures, or it's wind industry, or it's marine motions, or it's hydrodynamics, or it's some high-level geotechnical engineering, all these things I've just mentioned and what I've just described is my day-to-day business. Just highlight one of those little subjects, my ears will pick up, and I'll start to look. Oil and gas industry is, from a professional point of view, very rewarding in terms of the structures I conceive and play around with. Most of my structures become exposed. In some regard, they're in their purest form. They're not influenced by architects who are trying to cover them up, or perhaps change them in some ways to actually accentuate what they want to see. So in some regard, is quite rewarding. There's a reward of travel, obviously, in terms of this industry is multinational. You will probably see most extraordinary parts of the world. Oil and gas has a habit of being sometimes in the most forsaken parts of the planet in terms of climate. I've been near the Arctic Circle, I've been in the tropics, I've been everywhere you can think of. Oil has a habit of being in the most extreme environments. It's not in my back garden, but it's certainly everywhere else you can think of. And that in itself is also challenging. I've come across the most peculiar soil conditions in Kazakhstan. I've designed for ice loadings in the top of Russia. So all this stuff is quite exciting.